For more than a century, astronomers have been looking into the night sky and seeing something extraordinary. The farther away a galaxy is, the more its light is shifted toward the red end of the spectrum. This phenomenon, redshift, changed everything. It told us the universe was vast. It told us it was dynamic. It told us it was not static, but evolving. Redshift became the foundation of modern cosmology. And yet, beneath all of the measurements and equations, there was a quiet problem. We could measure redshift, we could map it, we could predict it, but we never truly understood why it happens. We told ourselves a story, and the story worked, but it was incomplete. The explanation we've been given goes like this: space itself is stretching. As space stretches, light stretches with it. The farther light travels, the more it stretches. The more it stretches, the redder it becomes. It's elegant, it's mathematical, it fits the data, but it leaves behind questions that never quite disappear. What does it mean for space to stretch? What is actually stretching? Why does it stretch more in some regions than others? Why does the effect grow with distance? Why do vast cosmic voids dominate the process? And when those questions became too uncomfortable, we introduced a new idea: dark energy, a mysterious influence that pushes the universe apart. We don't know what it is. We've never detected it. We can't explain its origin. It works in the equations, but nowhere else, which tells us something important. The math isn't wrong, but the story underneath it is missing something. Redshift can only arise in 3.5 ways: from motion, from metric stretching, from a medium physically stretching, or from the medium's internal state changing. Only one of these is a physical mechanism, and it isn't expansion. This is the part of the story we never examined. To understand redshift, we first have to understand light, not as a particle flying through emptiness, not as a wave traveling through nothing, not as an abstract symbol in an equation, but as something physical. As described in the spatial equilibrium theory, we begin with a simple statement: light is an oscillation of the medium itself, the same medium we casually call space, and that medium is not uniform. Near galaxies, stars, and matter, the medium is under higher tension. In the vast voids between galaxies, it is more relaxed. Light does not travel through a flat, featureless backdrop. It moves through a landscape of changing tension, and that changes everything. If the medium itself were stretching, that would be expansion, a physical growth of the medium. But if the medium's internal tension is changing, that is not expansion at all. It is a state change. And only a state change matches what we actually observe across cosmic distances. Here is the moment the puzzle finally locks into place. As light travels into regions where the medium is more relaxed, the oscillation itself relaxes. A relaxed oscillation stretches. A stretched oscillation has a longer wavelength, and a longer wavelength is redshift. That's it. No stretching rubber sheet, no exotic force, no invisible energy pushing the universe apart. Just a physical behavior of oscillation in a medium whose tension is changing. This is the missing mechanism. This is the moment the universe suddenly makes sense. Now, the most puzzling feature of redshift becomes obvious. The farther light travels, the more relaxed the medium becomes. So the stretching accumulates. Redshift grows with distance not because galaxies are racing away faster and faster, but because light is passing through regions of progressively lower tension. Redshift is not a speedometer. It's a map of how the medium behaves. There are 3 familiar kinds of redshift. Doppler redshift happens when a source moves through the medium, changing the tension pattern the oscillation travels through. Gravitational redshift happens when light climbs out of a high-tension region near mass into a more relaxed region. Cosmological redshift is the long, slow version of the same process as light moves through vast gradients of tension across the universe. Different contexts, same mechanism. Oscillation responding to the medium. Once you see redshift this way, several mysteries dissolve at once. Doppler redshift, gravitational redshift, and cosmological redshift are no longer separate phenomena. They are all expressions of the same thing, oscillation responding to the medium it moves through. The need for dark energy disappears, not because the data changes, but because the mechanism is finally understood. Acceleration no longer requires a mysterious force. It emerges naturally as the medium relaxes more freely in larger, emptier regions. And the universe stops being an abstract geometric construction. It becomes physical again, real, continuous, alive with motion. For over a century, we've watched light redshift across the cosmos and told ourselves we understood it. We built equations. We built models. We built an entire cosmology on top of a phenomenon we never fully explained. Why does light redshift as it travels across the universe? We said because space stretches. We said because of dark energy. We said because the math works. But now, with SET, we can say something simpler and deeper. Light is oscillation. The medium relaxes. The oscillation stretches. The wavelength grows. Redshift appears. Another mystery resolved, not by adding complexity, but by revealing what was always there. Next, we turn to the most intimate question of all: why time seems to dilate, and what time actually is. And that one changes how you see everything.